Welcome to the Explainer. So, have you ever really stopped to think about what's happening behind the scenes when you click on a link? Well, today we are pulling back the curtain on that incredible, invisible journey your request takes every single time you go online, all the way from your screen, across the globe, and back again, literally in the blink of an eye.
I mean, think about it. We do this dozens, maybe hundreds of times a day, and we never give it a second thought. But that simple, single action kicks off a hidden world of just incredible complexity and speed. So let's really dig in. What is actually going on back there?
You can almost think of that click as the starting pistol for a race. It sends a tiny packet of your data on this epic adventure, a request that has to navigate a global maze of hardware and rules just to find its destination, and hopefully bring back an answer for you.
All right, let's get into it. To really wrap our heads around this journey, we first need a map of the world that our little data packet lives in. Okay, so this image right here, it just nails the two fundamental zones. Over on the left, you've got your private world. That's your laptop, your phone, your smart TV, all that stuff. And on the right, you have the huge public internet. And that little box in the middle, that's your router. It's the gateway, kind of like the bouncer at a club, deciding what gets in and what gets out. So now let's meet the physical gear that actually gets your data started on its path. These are the devices that build the on-ramp from your private little network onto the massive global information superhighway.
Now, it is super important to get that these are two totally different jobs. The modem, that's your translator. It speaks the language of your internet service provider, whether that's cable, phone line, or fiber, and it translates it into a language your computer can actually use. The router, though, that's the traffic cop for your house. It directs that internet signal to your specific laptop or phone and manages all the different devices talking on your private network.
So how does the internet signal even get to your modem in the first place? Well, it travels down one of these physical roads. You might have cable, which just piggybacks on your TV line, or maybe DSL, which uses your old-school phone line. The real gold standard, though, is fiber, which uses pulses of light for just blazing speed. And of course, for places where you can't run a wire, you've got satellite and cellular.
And here's what this gear actually looks like in the wild. On the left, that's a pretty standard DSL modem, and you can see it connects with a regular phone jack. Then on the right, that's the back of a cable modem. The thing to notice is that round screw-on port labeled coax. It's the exact same kind you'd find on the back of your TV.
Okay, so our data has hit the internet highway, but how does it know where to go? Just like a letter you'd put in the mail, it needs an address. And to find that address, it needs a directory. So welcome to what's basically the internet's postal service.
So before your click can even think about leaving your house, your device needs a local address. You can think of it like a hotel room number. The second you connect to Wi-Fi, a system called DHCP acts like the front desk. It just automatically hands your device a temporary IP address so the router knows exactly which device to send information back to.
And this all happens through a lightning-fast four-step chat called Dora. It's kinda cute. First, your device discovers the network by shouting, "Hey, anybody out there?" The router offers up an IP address. Your device requests to use that one. And finally, the router acknowledges it, saying, "You got it, it's yours." It's this super quick back and forth that happens without you ever noticing.
You know, this slide shows a really cool evolution of internet addresses. The original system, which is called IP4, had about 4.3 billion unique addresses. And that sounds like a ton, right? But with every phone, computer, smartwatch, and smart fridge out there today, we basically ran out. It's a real problem. And that is why we needed the upgrade, IPv6, which gives us a practically unlimited supply of addresses for, well, the foreseeable future.
So, your device has an address, but what about the website you're trying to get to? You type in a simple name, right? But computers don't get names. They need numbers, an IP address. And that's where the domain name system, or DNS, comes in. It is, for all intents and purposes, the internet's universal address book. It looks up google.com and translates it into the numerical IP address that all the network machinery actually needs to find the right server.
So now we have the address, and the data itself needs to be sent. But you can't just have a chaotic mess of data flying everywhere. The whole transfer is governed by a really strict set of rules, or protocols, that are basically the rules of the road for all the data out there.
This slide does a great job breaking down the two main ways to ship data. Think of TCP as certified mail. Yeah, it's a little slower because it sets up a connection, it numbers every little piece of data, and it checks to make sure everything arrived perfectly. You absolutely need this for something like an email or loading a web page. On the other hand, UDP is like a postcard.
It's way faster because it just sends the data out and kind of hopes for the best, which is perfect for video streaming or online gaming where raw speed is way more important than catching every single little error.
Okay, so if an IP address is the street address of a giant apartment building, let's say Google servers, then a port is the specific apartment number for the service you need. Port 443, for example, is the apartment for secure web browsing. Port 25 is where you go to send email, and so on. It's what tells the server exactly what kind of request you're making when you show up.
So your request, armed with the right address, following all the right rules, has found its destination server, maybe on the other side of the world. But guess what? The job is only half done. The data you actually wanted, that web page, that video, now has to make that entire journey all the way back to you.
And here we are, back at our map, but now everything is happening in reverse. The data travels across the public internet, heading for your home's public IP address. Your router grabs it, looks at its internal list, and says, aha, this data is for the laptop at local address .104. And then it forwards that packet to your specific device and nobody else's.
So just stop and think about that for a second. The DHCP request, the DNS lookup, the TCP handshake, those data packets traveling thousands of miles through fiber optic cables and then all the way back to your specific device. The whole shebang happens in a fraction of a second. It's just a staggering feat of global coordination that we completely take for granted every single day.
And that's our deep dive into the journey of a click. You see, the internet isn't magic. It's a masterpiece of engineering, all built on these layers of invisible rules and protocols. Which kind of leaves us with a question to chew on. What other incredibly complex, hidden systems are working silently in the background to power your everyday life?